What is up, engine heads? Welcome to another episode of Boost School, the YouTube equivalent of a university course on forced induction, made possible by the glorious performance electronics of AEM. In today's episode, we're talking about something that is probably as important as boost itself, and that something is control. Because boost without control is like pretty much anything else without control. It kinda sucks. And in today's episode, we will explore all the different boost control setups, starting right from the most simple, most basic one, and proceeding all the way to the most complex, most performance-oriented setups out there. So without any further ado, let's get started. And of course, we're starting with level 1. So the simplest, most basic setup consists of your wastegate and your wastegate actuator. That's it. It's fully mechanical with zero electronics. And it works like this. The wastegate actuator has an arm which is directly connected to the wastegate. Inside the wastegate actuator there's a spring and a diaphragm. The spring senses boost pressure all the time because it's connected to the compressor side of the turbo via this hose. So any boost pressure generated by the turbo is exerted on the spring as well. The spring in this particular actuator is an 11 psi spring, which means the wastegate will be fully opened when the turbo generates 11 psi of boost pressure. So as you can see, it's a really simple setup. Unfortunately, being simple is its only advantage, and having your turbo spool up quickly with a setup like this is almost impossible. And the reason is that the wastegate actuator spring is exposed to boost pressure constantly. And although the wastegate will be fully opened at 11 psi, it will actually start to open at boost pressures well below that. Now this is bad, and you do not want your wastegate opening before reaching target boost pressure, because once the wastegate opens, it's going to divert exhaust gases away from the turbine wheel, causing your turbo to spool up slower. Another major drawback of this system is that it's dumb. It only references boost pressure. It has no idea about the intake air temperature or how much your throttle is open or anything else for that matter, and as you will see, that can negatively impact boost control. So let's say that you wanted to make more boost than what the spring inside your actuator is rated at. How would you do that? Well, you would trick the spring, of course, and the easiest and cheapest way to do that is with a manual boost controller. A manual boost controller is an extremely simple device that is installed in a line between the boost pressure source and the wastegate actuator. It usually features some form of manual adjustment, often an adjustment knob on top of the manual boost controller. Inside it, there's a little ball and a little spring. Changing the adjustment of the manual boost controller changes the amount of spring pressure exerted onto the little ball. And what the little ball actually does is that it delays boost pressure from reaching the wastegate actuator, because the little ball requires more pressure than the wastegate actuator to be raised from its seat. This forces the turbo to generate more pressure in order to raise the little ball off its seat and reach the wastegate actuator. Installing a manual boost controller is dead simple. It usually takes 10, maybe 15 minutes, but achieving desired boost usually takes a lot more time, a lot of trial and error, and many slow incremental adjustments. But when you combine a manual boost controller with an aftermarket wastegate actuator that can house different springs inside it, it really has the potential to change the nature of your turbocharged engine. But as you'll see, it's far from perfect. Although it does increase boost, the manual boost controller doesn't really do anything else. Just like our previous level 1 setup, the manual boost controller is dumb. It references nothing other than boost pressure, and there's nothing controlling the manual boost controller. And what can happen with a manual boost controller is that sometimes you can achieve full boost with half throttle. Another problem with manual boost controllers is that they can require frequent readjustment. A setting that works in one temperature and one elevation might not work in another. This problem can be especially pronounced if you drive your car year-round in a place that has hot summers and cold winters. The reason behind this, again, is that the manual boost controller is dumb, so it can't compensate for changes in ambient temperature or ambient pressure. At the end of the day, it's just one more spring that delays the compression of the original spring. So you again end up with a single boost value that can't be changed or controlled as you drive. Now we're finally taking things a step further, and the electronics are entering the stage. And what you can see here is an electronic 2-port boost control solenoid. And just like any solenoid, it features a coil of wire wrapped around the ferrous metal. When current is passed through the wire, it creates a magnetic field which moves the ferrous metal. In essence, a solenoid converts electrical energy into mechanical work or movement. In the case of a boost control solenoid, a plunger of some sort is usually attached to the ferrous metal, and the plunger opens or blocks a passageway through which pressurized air from the turbocharger flows. A 2-port solenoid is usually connected between the boost pressure source and the wastegate actuator with a T-fitting, and what it actually does is that it bleeds pressurized air away from this hose, reducing the pressure inside the hose. And this means that the wastegate actuator spring actually feels less pressure than what the turbo is generating. This then forces the turbo to generate more pressure than what the wastegate actuator spring is actually rated at in order to open the wastegate. Now, a solenoid has two major advantages over any manual boost controller. The first advantage is that it's connected to an ECU. The second is that it can vary the amount of air it's bleeding from the system. Now, you may think that the plunger inside the solenoid is either open or closed. In reality, what the plunger does is that it rapidly moves between the open and closed positions, doing so many times per second. Now, the amount of time the plunger spends in the on or the open position within a single second represents the solenoid's duty cycle. The longer the solenoid is energized, or the longer it is in the open or on position, the more air it will bleed from the system, which means that the actuator spring will see less pressure, resulting in it opening later, and this will enable the turbo to generate more boost. Now, because the solenoid is connected to the ECU can manipulate the duty cycle of the solenoid to manipulate the amount of air being bled from the system and thus boost pressure. Now, the ECU references a bunch of different parameters, which means it controls boost pressure based on those parameters. For example, the ECU can manipulate the duty cycle of the solenoid until it reaches desired pressure in your intake manifold. And because the ECU also references your throttle position, it means that you will never again experience the problem of full boost at half throttle with an electronic boost control solenoid. The ECU also references your intake air temperature and your coolant temperature, which means your performance will not vary like it would with a manual boost controller. So as you can see, the electronic 2-port solenoid solves two major drawbacks of the manual boost controller. It can vary boost pressure, and thanks to the ECU, it can vary boost pressure based on different important parameters. But the 2-port solenoid still has one major drawback, and the drawback is the way it's connected into the system. As you can see, it's teed into the system, and this results in the wastegate actuator spring still seeing boost pressure all the time. The solenoid is just bleeding air away from the system, it's not interrupting the boost pressure coming from the turbo, which means that it cannot prevent the wastegate from being cracked open at boost pressures lower than desired. For a method that actually interrupts boost pressure coming from the turbo, we need to step up to level 3. Enter the 3-port solenoid. The working principle is the same because this too is a solenoid, but the connection and obviously the number of ports isn't. Unlike the 2-port solenoid, which needs a T-fitting to be connected into the system, the 3-port solenoid doesn't need a T-fitting. It's connected directly into the boost reference line, and in fact it interrupts the boost pressure going through this line. The 3-port solenoid can do this because it has an additional port, which vents the pressurized air into atmosphere or back to the turbo inlet. As you can see here, the 3-port solenoid is connected to a single port internal wastegate actuator, but you can also connect it to a 2-port external wastegate or a 2-port internal actuator. When the 3-port solenoid is energized, it interrupts or blocks the pressurized air going to the actuator spring. By directly interrupting the air and venting it to atmosphere, the 3-port solenoid can keep more boost pressure off the actuator, which means it can help your setup generate more boost. Typically, a 3-port solenoid connected in this way will allow your turbo to generate twice the boost pressure of what your actuator spring is rated at. So if you're running an 11 psi spring like this one, using a 3-port solenoid can typically generate around 22 psi of boost pressure. Double the boost pressure is usually the limit, because beyond this point what often happens is that the actual exhaust gases generated by the engine itself will overpower the spring and open the wastegate. Additionally, because the 3-port solenoid interrupts pressurized air directly instead of bleeding it, it results in a more responsive and a quicker spooling turbo. It is both more accurate and requires less duty cycle to achieve the same boost pressures compared to a 2-port solenoid, which means it can give you more headroom to increase boost pressure and power. Combined with an aftermarket wastegate actuator that can house different springs, a 3-port solenoid will give you a lot of flexibility and a lot of room to grow. AEM's 3-port boost controller solenoid is designed to resist corrosion and sticking from exposure to rich fuel mixtures, and it's pressure tested to 100 psi, which means it's ready even for the most extreme racing environments and the highest of turbo pressures. It also includes high quality barb fittings to reduce any chances of leaks, and a filter that prevents foreign matter or moisture from getting into the controller. Now for this level, we're using all the same hardware, but we're connecting it differently. In our previous scenario, we have shown a 3-port solenoid connected to a 2-port external wastegate like this. Now a 2-port external wastegate is great because it allows you to exert pressure both on top and under the spring, which lets you better manipulate your wastegate. Now this type of connection is okay, but it functions very similarly to a single port actuator connection. Once boost pressure gets high enough to overcome the resistance of the spring, it will compress the spring from the underside and it will lift up the external wastegate valve. So this is okay, but what we're essentially doing is still just lying to the spring. We are bleeding air away from the system, and although a 3-port solenoid is better at lying to the spring, it can bleed more air and can do so with less duty cycle compared to a 2-port solenoid. There is a better way to connect a 3-port solenoid to an external 2-port wastegate. And you'll be connecting it like this. As you can see, a boost pressure source is connected both to the bottom of the spring and 3-port solenoid. You're probably already thinking, hey, this is stupid. You're exerting boost pressure directly onto the spring. It's just going to open the wastegate as soon as boost pressure gets high enough. But wait, boost pressure is also going to the solenoid and from there to the top of the spring. And what we're doing is using the solenoid to vary the amount of pressure received by the top of the spring. In our previous level 4 scenario, we bled pressurized air coming from the turbo in order to manipulate how much pressure was available to open the wastegate. But in this scenario, we are manipulating the amount of boost pressure helping the spring to keep the gate closed. Now let's imagine that our external wastegate spring is set to open at 15 psi. If the ECU manipulates the solenoid duty cycle to vent all the boost pressure that reaches it, then none of the boost pressure will reach the top of the spring, which means it won't receive any help counteracting the boost pressure coming from below, and it will open the wastegate by compressing once boost pressure hits 15 psi. Now let's imagine the ECU manipulates the solenoid to vent only 5 psi of boost pressure. This means that 10 psi of boost pressure will make it to the top of the spring. Now our spring becomes a 25 psi spring. It has its own 15 psi of resistance plus the 10 psi of help it's getting from the solenoid. Now making the spring stronger is better than lying to the spring, because the spring isn't just fighting against boost pressure, it's also fighting against exhaust gases pushing on the wastegate trying to open it. This is often why lying to the spring isn't able to prevent the combination of exhaust gases and boost pressure from slightly opening the wastegate before you want that to happen. When you make the spring stronger, you aren't just reducing the forces trying to open it. You're in fact actively countering them, which ensures that the spring doesn't open at all until boost pressure is actually reached. And of course, this noticeably improves turbo's pull-up and makes the turbo more responsive. Now imagine pairing this powerful setup together with a very powerful ECU, like the AEM Infinity Series 5 for example. Now this thing isn't just lightning fast, but it has many boost control strategies. It can control boost based on RPM, throttle opening, manifold pressure, intake air pressure, flex fuel content, you name it. But it can also control boost based on gear and vehicle speed, which means that if you provide it with an input of vehicle speed in the form of an ABS sensor or a transmission-based speed sensor, this thing can limit boost in lower gears, which means it can help very high horsepower vehicles or front-wheel drive vehicles retain traction even in the lowest of gears, which drastically improves drivability. So a powerful ECU with a good 3-port solenoid and an external wastegate is a combo that's pretty much perfect for any application out there. So I just said that a 3-port solenoid and a good ECU is pretty much perfect for everybody. Why am I talking about a 4-port solenoid then? Well, even a 3-port solenoid has its limits, and although these limits are reached only in pretty extreme cases, there are limits nevertheless. As we said, a 3-port solenoid can help you generate twice the boost pressure of what your actuator spring is rated at. So if you have a 10 psi spring, then a 3-port solenoid can help you make 20 psi of boost pressure. Now, what you have to remember is that your spring inside your external wastegate or your internal wastegate actuator is always going to be the lowest amount of boost you can possibly make. There is no boost control setup on Earth that can help you make less boost than what your spring is rated at. So let's imagine you want to make 60 psi of boost. Yep, that's 4.1 bar, which is obscene boost, but you want it nevertheless. And you grab your ECU and your 3-port solenoid, and you know that because you want 60 psi of boost, you need a 30 psi spring. So you grab your 30 psi spring, you install it inside your wastegate actuator, and you feel really good about yourself. Then you take your car and you try to get it off from the starting line. And all it does is spin the tires. So why is this happening? It's happening because 30 psi is the minimum boost you can make, and your setup is making it in first gear, second gear too. So unless you have some giant ultra fat tires or a stupidly advanced all-wheel drive system, you just created a burnout monster that has a stupid looking boost curve. So how do you fix this insanity? Well, enter the 4-port boost control solenoid. With one more port, it can do something that the 3-port solenoid can't. It can manipulate both the top and the bottom of the wastegate spring. When it's energized and at maximum duty cycle, it will send boost pressure to the top of the spring, helping it stay shut. And at the same time, it will vent pressure from the bottom of the spring, which means that the chances of it getting crack opened are pretty much zero. When de-energized, it will send boost pressure to the underside of the spring and vent from the top of the spring, ensuring it instantly opens the wastegate when needed. So let's get rid of our ridiculous 30 psi spring and replace it with a 10 psi spring to regain traction in all gears. Now the turbo starts making boost and the ECU energizes the 4-port solenoid so that it diverts the maximum amount of boost pressure possible to the top of the spring and vent from the bottom of the spring at the same time. This means that when the turbo is actually making boost, the underside of the spring sees pretty much nothing. At high duty cycles, this is close to atmospheric pressure. On the other hand, as the turbo is generating more and more boost, more and more of it is helping the spring stay shut. As you can see, this is a pretty aggressive scenario. That spring isn't moving at all until the solenoid allows it to do so. This is why a 4-port solenoid makes it easy to reach the surge limit of your turbocharger and have extremely aggressive boost response. In fact, a 4-port solenoid is actually capable of controlling the system to generate 5 or even 6 times more boost pressure than what the spring is rated at, giving you an absolutely giant boost range and helping extreme horsepower vehicles regain traction in lower gears. So this is perfect. This is what we all want, right? Well, unfortunately, the 4-port solenoid also has a drawback, and its drawback actually comes from its strength. Because the 4-port solenoid controls both the top and the bottom of the spring at the same time, changing the duty cycle can significantly affect the resulting boost pressure. When you change the duty cycle on a 4-port solenoid, you remove boost pressure from the top, but you're at the same time sending it to the underside of the spring, or vice versa, and this significantly affects boost pressure. This is also why many people say that 4-port solenoids have poor resolution. What it actually means is that when you change the duty cycle by as little as 1 or 2%, you change the boost pressure by as much as 3 to 8 psi. And this is why often 4-port solenoids produce a pretty erratic or bumpy boost curve. So how do we fix that? How do we improve that? We do this by using 2 3-port solenoids. 2 3-port solenoids can give you a giant boost level, but also a pretty smooth and linear boost curve. But they require a very complex, very advanced, very high-end ECU that can control them, and some very smart and very complex tuning. So to sum it up, a 3-port solenoid together with a good ECU and a 2-port external wastegate or a 2-port internal wastegate actuator will fit 9 out of 10 applications. This is an extremely versatile, a very flexible, and a very powerful boost control setup. It can give you great turbo spool up, great turbo response, a linear boost curve, and can also give you quite a bit of boost. On the other hand, 2-port solenoids and manual boost controllers, although they are inexpensive and easy to set up, aren't capable of realizing the potential of modern turbochargers and well-built engines. If you're looking for giant boost levels and extreme horsepower, then a 4-port solenoid or 2 3-port solenoids are the way to go. So there you have it. That's pretty much it when it comes to boost control setups. I hope this video managed to clear things up and it helps you visualize the kind of boost control setup you want for your vehicle. As always, thanks a lot for watching, and I'll be seeing you soon with more fun and useful stuff.